we know that the capacitor be able to store electrical charge. So when it's be able to store electrical charge, it also be able to deliver back the charge to the circuit. So today we are focused on how to discharge a capacitor. So we must know the simplest circuit. The simplest circuit for discharging capacitor. Alright, now let me sketch for you first. So when we want to discharge a capacitor, we must have a resistor. Okay, and this is my capacitor that is fully charged. Okay, oh, not in really straight line. My capacitor which is fully charged, and I have a switch. Okay, let me label it as switch S. Okay, and this is my capacitor. So the difference is for charging and discharging. Apa beza dia? For charging, if you still remember, we have a power supply on the left side here. But for discharging capacitor, we remove the battery. Okay, so when we remove the battery, you must know that Q in this capacitor remain constant. Okay, Q in this capacitor remain constant when we disconnected. So the Q stored is a maximum now in this capacitor, and it has a maximum voltage across it. Okay, it has V0. Okay, so if we have V0, Q is, I'm referring here, is a Q0, which is both is maximum in magnitude. Okay, right. Then kita tahu when it's fully charged, plate A of the capacitor now become all positive, and this plate B, okay, I'm using different color. Okay, all negative, right? So when you close the switch S, the discharging process will take place, right? Okay, so now what happened? Apa yang berlaku? So bila you close switch S, during this time, current that flow in this circuit is the maximum current. Current that flow through the resistor is the maximum current, which is I0. Immediately I0 will flow as you close the switch S. Okay, and you must know that when there is current flow, there must be flow of electron. Okay, there must be flow of electron. So electron will flow from plate B, and then it goes to plate A, right? So electron will flow here from plate B to plate A. What happened as the electron reach plate A? So when the electron reach plate A, it will neutralize the positive charge at plate A. Okay? And what you can see here, the directions of current flow for this charging process is opposite to the charging process. It's to the left now if we compare to the charging circuit, because charging circuit you have a battery here, positive, negative, so supposedly your current will flow in positive direction. Okay, so now we remove it, so the flow of current for this charging process is in opposite direction to the charging process. So now we want to study what happened to this electron. Okay, so when electron reach plate A, it will Okay, it will neutralize. Okay, it will neutralize. You can see on the left side, I give you a fully note. Okay, so it will neutralize positive charge. Okay, it will neutralize all the positive charge at plate A. Okay, when it's neutralized, what happened across a capacitor? Voltage that just now is a V0 now start to decreasing. So V starts to decrease to a certain value. Okay, and when V decrease, I will also decrease. Okay, and both quantity here will decrease until V equal to 0 and I also approximately equal to 0. So when V equal to 0, I equal to 0, we said now the capacitor now is fully discharged. Okay, now it's fully discharged. The capacitor now is fully discharged. Okay, that's all for discharging. Later on, I will show you how we represent these changes in a graph, exponential graph.